So the first graph we're going to do is problem 47. It's y equals negative sine of 2 pi thirds x. So before we even think about graphing the function, first thing we need to do is we want to know its shape. So it's a sine graph. We know the regular sine graph starts at 0 going up, but this is a negative sine graph, so it's going to start at 0 going down. So I'm just going to put that information down here. It starts at 0 going down. We will calculate the period. The period is equal to 2 pi divided by the number in front of the x inside of my trig function. So divided by 2 pi thirds is the same thing as multiplying by 3 over 2 pi. I'm going to cancel the 2 pi, so my period is 3. So that's one complete cycle of my graph. We have no horizontal shift or vertical shift for our graph. So first thing we're going to do is we will use our period and come out here and label our period. Then we're going to divide that region into fourths. So this would be 3 halves. This would be, so that's 1 1/2. Half of 1 1/2 would be 3/4. And 3/4 plus 3 halves, that would be 6, 7, 8, 9 quarters. Let's go the other direction. This would be minus 3/4 and minus 3 halves. The maximum of my graph is the maximum of my regular sine function because I have no vertical scaling. So what we're going to do is we are now going to graph our 4 key points on our primary interval for our period. So we're going to start at 0 going down. And at each quadrantial angle, we are going to go to the next point. So starting at 0, going down, then back to 0, then up to 1, then back to 0. Opposite directions for the negatives. And connect them with smooth curves. Arrowheads on both ends. And that would be the graph of negative sine 2 pi thirds x. Next graph is y equals sine of x minus 2 pi. So again, the first thing I want to know is which direction is my graph going? My graph is a sine function, so it starts at 0. It's positive, so it's going to be going up. My period is 2 pi divided by the number in front of the x. So 2 pi divided by 1 is 2 pi. I have no amplitude changes, so my maximum and minimum are again going to be 1 and negative 1. What I'm going to do now is mark off 2, because that's one full period, divide it into fourths. And I am now going to dot in my graph. I do have a horizontal shift here, but I'm going to just dot in the graph, and then we're going to do the shift and then solidify it. So I start at 0 going up. Backwards in the negative direction. And what this is my horizontal shift. Because I got a 1 in front of the x, that's my horizontal shift. That is a shift 2 pi to the right. So what I would do is I would take every single point and shift it 2 pi to the right. Well, if I take this 0, shift it 2 pi to the right, I get back to 0. If I take this pi, shift it 2 pi to the right, I'm going to get back to 0. So a shift of 2 pi gives you back your original graph. And that should make sense to you because it takes 2 pi to go all the way around a circle, and I get back to where I started from. So this right here is actually not needed. The same graph could be just graphed with the sine of x. So if you know your trig identities, and you know the periodicity of your trig functions, you could actually sometimes simplify some of those functions. Next graph is 59. Y equals 2/3 cosine of x over 2 minus pi fourths. So first thing I need to do to what's inside the parentheses, I need to factor out a 1/2 out of everything, which means divide everything by 1/2. So if I put a 1/2 out here, I'm left with x and negative pi fourths divided by 1/2. Dividing by 1/2 is the same thing as multiplying by 2. 2 over 4 is 1/2, so this would become pi halves inside the parentheses. That is the toughest part of this whole problem, is factoring out the 1/2 that's in front of that x. Okay, same thing here. It's a cosine function. Cosines start at the number 1 going down, and it's still going to be the fact here. So cosine starts at 1 going down. My period is 2 pi divided by 1/2. Dividing by 1/2 is the same thing as multiplying by 2. So period is equal to 2 pi times 2, which is 4 pi. My phase shift is pi halves to the right. And I use the phi for my phase shift. Okay? So I now have enough information. Oh, and my amplitude is 2/3. No vertical shifts on this one. So I'm going to be horizontal at 0. So first thing I always mark off is my period. My period is 4 pi. Divide that into fourths. Half of 4 pi is 2 pi. Half pi is pi. And halfway between here would be 3 pi. In the opposite direction, I'd have negative pi, negative 2 pi. My graph is now going to cycle between 2/3 and negative 2/3 because that's my amplitude. And then it's going to have a phase shift to the right of pi halves. But I'm not going to do that until I dot in my function. So here's my maximum and minimum. I'm just going to put dotted lines here. So I start at 1 going down. And I get back to where I was at the end of the period. So notice again, all I have done is I have dotted those in. Now what I'm going to do is I'm going to take into account my phase shift. I am going to take every single dot on this graph and shift it pi halves to the right. So at negative 2 pi, I'm going to go and shift it to the right. Negative pi, shift it to the right. Shift each one of these to the right, pi halves units. And when I get done, now I'm going to connect my curves, my dots with smooth curves. Okay. So far, all of my graphs have had y-intercepts of 0, or if it was just a regular cosine function, it would have had a y-intercept of 1, or whatever the amplitude was. But this one had a horizontal shift. If you want to know what the y-intercept